Okay, we also check. Okay, so we can start it, and this is again kind of a learning exercise for us. Like why we are starting this is there is lots and lots of traction coming toward Databricks, and like you all know that we are doing a small POC around it, like where Ria created that deduplication script and we want to deploy it inside the Databricks environment. So then Raj got some success into it, and then we start digging it into more. And I am also going through these Databricks trainings and all those things. We started it way back, but we were not able to complete this. So we thought of like again starting this back, and let's see how much all of us are learning. So it's more of a collaborative kind of a session where you guys can also pick up few of the topics which are like commonly used nowadays, and why Databricks is getting too much of traction these days. We can discuss on that part, like what is the things that are making it so special, and what are the capabilities. So I will just set up a quick context, a theoretical background, how it started, who all are the founders, and how this all comes into the picture, and what is the things that are giving it so much of force in today's market. So let me start with the slide. So Databricks is basically there are few things which are like commonly confusing many of us, like what is Azure doing here and what is Databricks. So these two are different things. Like this is what Microsoft has invented, and this is what Ali Godse has invented. So these are the two different companies, and why the word is commonly used nowadays. We can look into that. And before starting that, like we all know that there was a Apache Foundation, which was behind many open source platform in the era of 1990s. Like when this whole episode of .com is starting, Apache was behind the scenes. So they were behind the Java and all other things. So at that time, Apache Spark engine is already invented by in UC Berkeley. UC Berkeley is University of California, Berkeley, with 9 people. They all collaborated together. So it was like their college project. They were doing some kind of a college project where they figure out like this can be one of the engine which can be used. So Apache Spark was invented in the early years of 2009. And then what it is like, it was a lightning fast unified analytics engine for big data processing and machine learning. So these guys, what they did is they invented some kind of an engine where it was like a small project, as I mentioned, and then they donate this to the Apache Spark Foundation. And this foundation, what they do is they give it to Yahoo, eBay, and Netflix, because at that time large scale data processing was started in US, as these companies are into their earlier stage, and lots of data are coming from Netflix streaming platforms, from eBay, the e-commerce website, and the Yahoo. We all know that for the mailing services. So lots of data start getting generated in the year 2009 in United States, and then Apache Spark Foundation purchased this project, and they started working on this. At the same time, Hadoop clusters are also working for the compute job. So what this basically means is, like in the today's world, we listen a lot about data centers, the clusters, and all those things were not present at that time. So at that time, someone was into their garages, they are putting up the CPU and the racks, and then they are starting the things. So first thing that was invented was Hadoop. It was a kind of a compute thing which was invented earlier. So the large data processing jobs are always running on the Hadoop clusters, and Hive was a language which was introduced by Hadoop to help out. So we whenever we learned this, Hive was there and Pig was there. So these were the two languages they invented to run the Hadoop clusters. But since Hadoop clusters were not that much powerful, or we can say that like whenever the iterative kind of a compute jobs were there, there is some kind of a shortcoming. And at the same time, these students have donated their Apache Spark Spark engine to the Apache Spark Foundation. So Spark start making it more comfortable. So it was 100x faster in memory computing, and it also packaged some of the standard libraries. What does this means? Like machine learning libraries and the other libraries, all of these are properly packaged inside the Spark. So Spark start providing the libraries like nowadays we look into the Python, we see that pandas are there, MLlib is there. So these are high standard library for machine learning, for streaming, for SQL queries, and for the graph processing. So in order to create a complex workflow, Spark getting more traction than Hadoop, and in this way, like Spark moves ahead in the market and from Hadoop. So Spark engine is taking up the traction. Now, let's look into the architecture. What was a Spark architecture? So, if we talk about any of these engines or any of the unified platforms nowadays, they have all the capabilities. So, at the core, again, Spark also has support to all the languages, which are like Python, Scala, Java, and R. These are all four powerful languages. And then it works on, so if we want to schedule some kind of a task, we want to do memory management, fault recovery. Like if one of the domain is getting faulted or one of your rack is getting faulted, the next rack will come into picture. So same thing like what Oracle has in OCI, same thing was in the Spark core, and the storage systems were also developed. So this Spark core can easily communicate with RDD. RDD is nothing but the storage systems. So it's a kind of a collection of items or rack distributed in the cluster for parallel processing. And this all is being developed on the top of some of the APIs. So for APIs development, they feel that there are lots of drawbacks, like everything cannot be captured or done by API. So then they invented one more thing on the top of this Spark core, which is known as Spark SQL engine. So first they invented this one, Spark core, and then Spark SQL engine come. So when Spark SQL engine was invented, then they started two different projects. One was Catalyst Optimizer, another was Tungsten. So Catalyst Optimizer was nothing because they feel that using only APIs, you cannot derive the complex workflow. So you need SQL queries as well. And in order to optimize those query optimization plan, they introduced this Catalyst Optimizer. So what it was doing inside the Spark, whenever you write any complex SQL query, like right now we did it in Informatica, and behind the scenes, those are the SQL queries for which optimized execution plan was created by some of the engines. Same way, Spark engine created a query execution plan to execute those queries. So this was the task of Catalyst Optimizer, one of the project of Spark. And then what Tungsten was doing here is memory management and CPU efficiency. Like if you are running 2 or 3 queries or more complex queries or 1,000 line of codes, how memory will behave behind the scenes, how CPU will show the more and more efficiency. So in this way, this was a second layer of Spark, which is a Spark SQL engine. Now, once these both got stable, like core is there, engine was also established, then they want some of the libraries, because at the same time, like Python was giving too many free libraries, and we need like some kind of high standard libraries to do our jobs. So then they invented this, the third option, where they give a special privilege to Spark SQL, which is something similar to what SQL queries that we are using. And then Spark streaming comes into the picture, which is like now Apache Kafka streaming thing, which Databricks is providing, and same ML libraries and the Spark graph libraries were also invented. So all these four high standard libraries are provided, and then data frames and dataset APIs are also provided. So these APIs can be invoked from any of the below language. So they provided the standard APIs, and then those APIs can be called using Python, Scala, Java, and R to create to process those big data jobs. So big data, in order to compute or do some kind of an analysis on those big data workloads, all this has been invented. So this is the third layer of the architecture, where developers can create their applications using higher APIs calls. And at the same time, then next layer, which is called Yarn, Apache Mesos, Kubernetes, these all are required. These are all standalone resource manager, because when so much of compute and everything will start, Yarn was already invented at the time of Hadoop. So they also get collaborated with Yarn as well. And then Apache Mesos and Kubernetes. So these all are kind of a resource manager that start working on it. And then Spark architecture get a very good shape. And we all know that at some point of times, there are lots of things we heard about Spark. Like Spark, people know Spark as one of the language, but actually it was a complete architecture. And then after that, what happened? Combining all, Spark provide a uniform platform for doing streaming jobs, machine learning jobs, graph processing workloads. So basically, graph processing workloads are more commonly used in these days for ML things. So what are these graph processing workloads? Like any kind of a pattern recognition or connecting the nodes, or Gremlin is also one of the language which we heard a lot in these days of OpenAI. So Gremlin and Cypher are two languages which are used to connect the different kind of a node and shortest path computation. So these all we have done in our college days. Like there were algorithms we write to find out the shortest path, connecting the nodes, pattern recognition. So basically these all are ML models, which we called as a graph processing workload. And whenever we talks about any kind of a pattern that we have to identify, graph languages are more into the picture. So Spark has an library to process these kind of workload as well. So a single execution engine and standardized set of APIs are all packed inside this Spark architecture, and this start getting more precedence over Hadoop architecture. Then what happens? Like Databricks got invented because see we have everything in place now. We have core, we have SQL engine, and we have the common libraries in place. But we all know that we need some kind of a Jupyter style IDE where we should write our code and we should start the cluster or spin the cluster. So in order to provide that unified UI kind of a thing, Databricks comes into the picture. So Spark is the fast execution engine. So to work with Spark, we need to set up clusters because we have to start the CPU cores which are behind the scenes. We have to manage some kind of a security. We also need some kind of a third-party tools like some kind of a Jupyter Notebook or VS Code platform where we will deploy our code, we will write our code. So in order to rectify all these things, Databricks was invented. And again, Databricks was founded by Ali Godse. In the picture, you can see he is the CEO of Databricks and the key contributor of Apache Spark. So when we are talking about in UC Berkeley, seven people together invented Apache program. So one of them was Ali. So during his college days, he was behind this Spark architecture, which was then given to Apache Spark Foundation. And again, he was behind the scenes who invented the Databricks. So he already know how Spark engine works. So he started the company and he was a CEO of, he's currently also CEO of Databricks. We will see him in all the summits of Databricks that are going on and the key contributor of Apache Spark. So this means that he invented the Databricks. He gave us a unified layer where we all are going to get work. And behind the scenes, Apache Spark engine was working, which was invented in the year 2009 by the same guys. So now we can see that if we go here, so what basically in the core of Databricks, you can see the same Apache Spark architecture where you can create the clusters. These are like general purpose cluster or memory optimized clusters and compute clusters. So different kinds of clusters they are providing. So there is a 8 or 9 different type of cluster which Databricks provide us. Then workspace or notebook is kind of a Jupyter notebook style IDE they provide, but it is not Jupyter notebook, but a kind of a similar style which Databricks provide us, which Raj is going to give us a demo on that, and then Git repository for the same thing. Administrative control, we all know that what is this, like users have the access and all those layers we can create. And then optimize Spark. So this is like a vanilla Spark they invented, which is kind of a language to write down the programs on this Databricks, which is like one of the more flexibility they provided. If someone wants to write a program, they can use vanilla Spark as well. Then we can also create databases and the tables inside this Databricks environment. And then Delta Lake is an open source platform with acidic property. So atomicity, consistency, integrity, and duplicacy. So ACID properties of database are provided into Delta Lake. This is similar to OneLake and all those things where all the raw data is coming. So here then Fabric is coming into the picture. In the same way, they have the Delta Lakes. So this is basically used to avoid the duplicacy. So the powerful thing of this is whenever you will insert the records, Delta Lake will easily identify that you are inserting a unique records or the duplicate records, and it start giving the warning signs. SQL Analytics is already provided to create the dashboard, something similar to Power BI. ML flow is for the machine learning model and the registry kind of thing. Clusters we already discussed. So these all functionalities are provided by Databricks on the Apache Spark, and it makes it Databricks. Now, why it is called And this Databricks is now available on all the three major cloud platforms. So it is Azure, it is AWS, and it is Google Cloud. And just 1 week back, they also are available into SAP HANA now. So SAP HANA and ECC also have a Databricks now. So in this way, what they are basically doing is like the same way, like as Informatica is collaborating with each for their connector thing. Databricks is also connecting with each of the major technology player. So in one of the seminars, someone is saying that SAP Databricks has been invented. So this is also like everywhere they are giving this cluster to utilize it. Now, why it is known as an Azure Databricks? Because with Azure, they integrated very deeply. So with Azure integration, they are much deeper than others. This means that when we are purchasing Databricks, we are directly purchasing Databricks from Microsoft. So they have some kind of an special agreement with this. That is why, and a very deeper integration into Azure. Like we can easily access Azure Blob, Azure clusters, and all those things. So there is a separate discussion on all this. So we can start this session. If we find it interesting, we can add on more slides into that. So that is the whole story of Databricks, how it invented on Apache Spark, then it become available to all three cloud, and then it integrated tightly with Azure, and it is known as Azure Databricks. So over to you, Raj. You can now share your screen and show the UI of Databricks and all those
Yes.
things that.
Okay. So yeah, that was a really nice high overview. So guys, like awesome. And in this session, if you have any kind of doubts or any question, just ask those, because we know that we all are new to this thing, so we can go with collaboration here. Okay. So basically, we are not using the Azure Databricks right now because we don't have the license for that. But we are using the free version of Databricks, the actual company, the actual Databricks, not into the Azure. But that doesn't make any difference, because both the UIs are completely same. Everything is same, just the name is different. They will give us Azure Databricks here. Okay. And one more thing is different is like we are unable to connect this thing to directly to the Azure right now. If we are on the Azure cloud for the Databricks, that is very easy thing. We can connect to all the services which Azure is providing to us. We can directly connect to them. Okay. So now this is the main UI we can see on the Databricks. Before just starting, I just want to clarify there are two accounts I have created. First one, which actually I just we don't have the remaining limit for this one, and this one I created newly for our demonstrations. So that is the one thing. Now let's start with the Spark. Okay. So for Spark, couple explain that it is a like distributed computing engine, Spark engine. So what does that mean actually? Okay. So here you can see there is one driver node and lot of worker nodes. Okay. So you guys know that we have the CPU, and without CPU we cannot do any calculations or anything. So let's suppose this is the CPU we have, and it has the 4 cores, and each core have 2 threads. Okay. So each core will get taken by one worker node, and one of them is the driver node. So what they will do, let's suppose we need to sort one data like 1,000 records. So Spark will distribute that data across all these cores. Let's suppose 300, and they will calculate on their own. After that, driver node will say like, yeah, now individual sorting is done, now group them and now sort it completely. So it will be a faster solution to sort, or faster solutions to do the like big things, large scale calculations we can easily do with the distributed structure. So this is the basically the distributed computing which we are referring in the Spark. So what they have written can handle the batch and real time data. So these are the two things we are using a lot in this session. Because what is batch? So you guys know we in Informatica we are creating the files, we are doing everything. But what is batch? We are running a job from extract to transform, extract to load, and that file is getting created. That is a batch. We will do it again whenever it needed. But what is real time? Let's suppose there is one sensor which is sending the data continuously to the database. So that is the real-time data, okay, which is going in the real time. It don't need any manual interventions or manual triggering. So it can handle both. Fast in-memory data processing. Due to this architecture, it is fast and scales across many machines. Okay, so let's suppose we will keep this driver node, and these worker nodes are not the CPUs right now. Those are like different computers. We can do that thing also using Spark. It will give us more computational power. And in Spark, mainly we will see PySpark and Spark SQL, these two things for our Databricks. So in PySpark is basically the Python which is using the Spark engine. Okay, so programming language is completely same, Python and PySpark. Just the libraries which Python is providing, those are not supported into the PySpark. PySpark have their own data frames. Okay, so we need to make sure that thing. And then SQL, which again useful for the big data communication, and again the data frames we can use those. And using the Databricks, we can use PySpark and SQL in the same notebook. This is kind of architecture Databricks is providing. So any questions on this Spark architecture?
So Raj, one question, like first is on the account creation. You are saying you created it 2 times, so this means that we can create any number of times, right? That there is no issue with that. If we want to,
Actually,
if this account
Raj,
again got expired, we can create a new account.
actually you can see this account is Raj Dange photo 1, and this one
Okay.
is the photo 2, I guess. Like we need to use the
Okay.
different account.
We have to use a different email
Yeah.
ID for that. Okay.
And as you asked this question, so I'll just clarify one thing here. Versioning. You can see there is one 24th point. We are using GitHub versioning. So what I
Okay.
did from this account, let's suppose in this account my workspace is under let's suppose users. This and I created this Databricks, which is a repository for me.
Okay.
All these tables are in this repository, and if I open my GitHub, you will see those things here.
Okay. So that is why when you are creating a new
Yeah.
account, this GitHub is getting linked to that.
Yeah, so what I did in this is old account. In new account, I went to my account, let's say settings. You need to link the account. This GitHub link I linked. We give the Databricks folder this repository access, and when we go to the workspace, you can go to the whatever. Let's suppose not this one in user much. I suppose here, and we can pull that actual code.
Hmm.
Okay. If
Okay.
you go to
From
the
the
Git,
GitHub.
you have this pull request, or you can push whatever
Okay.
unit. You can do that. So this is the one point versioning. What it helps. Let's suppose this is one user. This is Kapil, and this is Raj. Okay. So Kapil is doing their work in this notebooks, and now we want everything on the same page, everyone on a same page. So he will push this code into the GitHub. So it will get updated here. And then if I pull that from this GitHub, I will get the same code which Kapil is done there. And while pulling or pushing, we get some options to choose whatever we need to update, whatever we don't want to. And this main branch, like we have multiple branches here, main, or we can create anything. So those are project related. We can go in depth in the next session for the Git. So let's suppose let's start with the main UI now. Okay.
So Kapil, I
So
see
first,
that the user interface here, like the provision to use Python as well as SQL, is very similar to the Snowpark that we had in the. I
Hmm.
remember I was working on Streamlit application, so it is very going with a very similar flow to
Yeah,
what we have in
all,
Snowflake.
correct. All technology partners, even yesterday, Intellect AI, one of the company got invented. So they are offering all these computes very freely in the market, like a full page ad was there. They were also providing the same IDE. So what they are doing is like everyone is providing a unified kind of thing so that people will use to like we have Android kind of a UI, the skin. So this is same in Snowflake, in Fabric,
Yes,
in Databricks, in Azure Databricks. So all the interfaces are because there is a kind of a standardization around it
Mm.
now.
It aids usability. Very true.
Yeah. Yes. So even Raj, if you can, okay, you will come to this, right? Where you will be
yes,
explaining what is on the left hand side, like machine learning
everything.
and all those. Okay.
Yeah. We completed the Spark. Now let's go to the compute engine warehouse. Okay, I'll explain this thing first because that is the main core. So you guys know in IICs we have the secure agent where all the computations will happen.
Mm.
So here the same concept is there as a warehouse where all the computations are going to happen. Okay, so there are actually two terminologies. One is warehouse, one is cluster. So in free account we don't have the cluster. They don't have the permission in free account, but we have the warehouse. So this is the compute engine for the Databricks right now. And if you go to the catalog, this is databases. Like whatever data we have, we are storing it here. Okay. So basically, in old-fashioned warehouses, what is happening? That warehouse contains the data also and the compute power also. But now, what is happening? Snowflake and Databricks, what they are doing, they don't want to spend a lot of money on data and less money on compute. So what they are doing? They are storing this data on their partners like Azure Blob Storage or S3 bucket of AWS. They are storing this data on those partners, and for compute, they are using their own warehouses. So for compute only, we are using this warehouse, so we can manage the power and the usage based on our activities, not on the size actually. So that
Mm.
is
Yeah,
the
very,
major
very
thing they
nice
have
point.
improved.
Yeah, that you are saying. Say that again. What is you say that companies are spending more on like data they are pushing to the cloud, right? And
Yes,
compute
cloud.
they are start selling. They are putting more attention to the computes, right?
Yes, actually, in old warehouses, what was happening? Let's suppose there is a one machine with 12 GB RAM. Okay,
Right.
so and it has 1 TB data data storage. So they will say it as a warehouse. So what is
Mm.
happening? To improve the 1 TB data, they need to improve this 12 GB also, or to improve this 12 GB, they need to update the data also, so they can
Mm.
handle each other. So now what they are doing, they are not considering this thing here. They just need the resources for computing, so they can
Mm.
add this thing without adding the data. So let's suppose they added for the 50 GB. Okay, but for this 1 TB data, they will use the Azure or AWS S3 buckets. So they are directly independent. They are not dependent on each other, the compute and the data.
Hmm.
So
And
if
other important point is like in one of the project I see like earlier what was happening like if let's say we are connected to Azure, then we need to do some kind of a compute or some kind of an operation on that data. We need to get that data into our ecosystem. But nowadays like pointer system is allowed
yes,
where we can do the same operation inside Azure from Databricks. So this
yes,
means the data will stay there, but compute will go from Azure towards from Databricks to Azure.
yes. So they are doing this in
This is
pricing
right.
also.
Compute and
For
storage are
yeah,
separate now.
for
Uh,
storage they will ask us to let's suppose $100 for 1 TB. That is
hmm.
on the one time pay. But for compute, it will be like pay as you go.
Yeah, pay as you go, and the clusters will spin and the cost will be calculated.
Yes,
Once your cluster will stop, compute will stop.
compute will stop. So
And
that is
auto
the thing.
suspend is the functionality which everyone is taking from Snowflake. Like as we know that the those t-shirt sizes
Yeah,
clusters got auto suspended.
you can see the auto stop option in the this warehouse.
So
Okay.
Okay.
Kapil,
Hmm.
like compute is basically the operations that we want to perform. So
Yes.
we'll be paying separately for that. And the
Hmm.
warehousing is simply storing of data, isn't
Yes.
it?
Correct. Correct. Yes.
So
Yes.
I'm not getting like how are they, managing it differently?
See, there will be two bills will be generated. So if we go to the OCI, so they have done is like earlier, what is happening, like every cloud provider, they want to provide the compute as well. So they are saying that, okay, if you are with Azure, I will store your data in the blob container and I will provide you the compute. Then the system start changing up because this compute, as I explained you, like graph load processing. So this graph load processing ML job is very critical. So let's say there are multiple studies. So from healthcare side, I can present you one of the example where there are multiple kind of reports, those sonographies and scanners and all those things. Then these graph processing node traverse through those reports, and then they can predict like this cancer can be curable or not curable, and what is the life of the patient, how far he can go. So that kind of a predictive analysis based on the graph load processing, those jobs can be executed, and these are very cumbersome job. So then compute start getting up traction, and compute is not a very small thing. Like you have to go from one node to the other node, you have to connect it. There will be multiple algorithm, very complex algorithm, which will start playing in the behind the scenes. And storing data is a different kind of thing. Again, that is also blob storage. We see high redundant storage, low redundant storage. So there is a different dynamics around storing the data, and there is a different dynamics for the compute. So then these cloud provider, the three cloud provider, Azure, GCP, and
AWS.
AWS, all understand that if we try to combine it, still AWS has not removed it. Like AWS is still in the combo state where he's saying that I will provide compute plus storage, and maybe because of that, this cloud is getting less traction. Earlier, AWS was number one player in the market, so they identify that storage is not our job. If we play around storage, someone will take the ground of compute. So then these systems arriving up, and here we can see like now what they are saying is, okay, we have the storage, and then they are collaborating with them. That is why Databricks is now selling their product to the three cloud provider, to the SAP. So SAP will provide their compute, SAP will provide their storage into the HANA or ECC, but compute will be given by Databricks. So, and everyone agrees that, yeah, this is a good model.
They
So that is what,
decentralize.
yeah, they decentralized it. And then again, the new approach which is coming out is pointer. Like we don't want to download all the data from Azure Blob to somewhere into the Databricks cluster. So let the data be there, and compute will be sent it from here. Like one cluster will spin up here. There is some kind of a dynamics behind the scene. As we discover more, we will come to know. That is also very interesting thing. Like without downloading the data, we will just send one URL which is pointing towards, like if you know that when we go towards the blob, we see one of the URL is there in the Azure blob. When we look into our data sets, so same URL will go and do the work inside Azure on that data. So that is why compute is plus storage is now separate.
And
So
they are
basically,
providing that pay as you use kind of feature, right?
Yeah, pay as you go is now mandatory, like it is provided by everyone. Earlier, it was that like there were two kind of a licensing fees. We will charge you this much amount irrespective of your usage. So all because AI was also new and cloud was also new, so everyone agrees that. And how they sold it, they were saying that if you provide us this much amount, we will provide you all the features. If you will go with a smaller package, you will get less compute, or you will get this and that. So everyone was getting confused, and they are paying the full licensing fees. But as industry is getting matured, they come to know that we 90, 70 or 80%, somewhere there is an article like all companies are not using 70-80% of their licensing fees. So then this problem was identified, and now pay as you go is the universal concept. Like all the companies are providing it.
Okay.
yeah. So basically, Lukman, this is the architecture like what Databricks and Snowflakes are using. They are using the CPU. Like, what is the compute? Compute is like we need some CPU processor, some RAM, some GPUs to process the graphs and the computational power. But the data storage, we just need the plain data storages like S3 buckets or the blobs. So what they are doing in the backend, they are using this structure for their databases and this structure for the compute. and we are just seeing everything in the one UI, like here only, like in catalog, all these things. In the compute, you can see the warehouse, and
Got it.
then
Thank
you
you.
can, yeah.
Thank you, Kapil and Raj, for this brief understanding.
Okay, so this is compute engine, and what is cluster? Cluster is same like the compute engine, but it have the thing like we can manage the size of cluster in very small level. Okay, so we can create multiple clusters for one simple task also. Then your question will come like, why we need multiple clusters for simple task? So there is one thing, acid acid properties. Okay, so let's suppose you have one lakh records and you need to process them in parallel processing for the fast results. But what are those records? Those are the bank transactions. So you
Okay.
don't want them to like interact with each other. You don't want to get amount from one and take it in
Add
the
it to
second
other.
one. That will be, yes, that will be a very difficult thing. So what we will do, we will create 4 different clusters, and we will provide one record to each cluster, so they will be isolated from each other. They are consistent, like they will proceed only one record at a time. Okay, and A is like atomicity. It is like they will complete or they will completely fail one record. It will not partially success. So this is the thing cluster is providing to us, but unfortunately we are unable to see this thing because of the free trial. And okay, so these are the core components for the Databricks, and you understood these things, how it works. So now let's go with the UI. Okay, so I'll
Does
start with
acid
the
have some full form? Like,
Mm,
is it an
atom,
acronym?
atomicity.
atomicity, consistency, integrity, and duplicate.
Yes,
Okay.
durability.
Durability, yeah. Okay, it's
Yes,
not duplicate. Okay.
yeah. So let's go with the main UI. So let's see in the new, you can see these many options. Okay, so notebooks are the main thing in the database where we will write our code in the PySpark or PySQL. Okay, so once you click on this notebook, you will go to the workspace. Okay, what is workspace? So in Informatica, you know the folder structure, that df Swiss, df Paramount, those things. So same kind of thing is
Explore
here.
option.
Yes, all these things. You can go in the hierarchy. Let's say workspace, in that user, in that Raj folder, in that Databricks we have. And let's suppose this one. This is the notebook we have. Okay. So here you can see I have created 3 cells. You can create one more cell like this. You can click on code. You can select the language. Okay, and you can write the code.
So
That is
Kapil,
the
I
main thing.
remember in
Hmm.
worksheet and notebook, worksheet is an option which provides us to run any code, be it Python or SQL. But in
Hmm.
worksheet, you can run only SQL, isn't it?
Yeah. Here also same thing. There you have the worksheet. Here you have the queries.
And
Option.
Raj, I also, when I was studying this, it was written that Databricks is capable of automatically generating comments, which can be then used for machine learning models. So let's say from line 1 to 38, you have written this code where you have put CH Switzerland and something like that. Have you explored this? Like it is automatically generating comment for that block of code?
Yes, actually, it will generate. I'll show you while creating these dashboards or
Okay.
creating the catalogs. In code,
Yeah.
I have not tried, but in catalogs, let's suppose catalog is mainly the databases.
Hmm.
So let's suppose I'm creating this PySpark DLT. So he will give me here the credits are all done. The morning only I created this second account, so it don't have all the things, but still we have a lot of things here. So see, for the description, it is analyzing the complete thing, and it is giving me the description. What description
Okay,
you can
table
give to
contain
the
customer
database.
category information, including details, customer name, all the this. It also includes identifier for source system. This data can be used for segmentation. Okay. Okay. So this is very nice. And if we accept it, what will happen? Like it will be pasted on as a metadata description, right, of
Yes,
this table.
yes, Yes, it will be the description for us.
Okay. So
Yeah.
this is
So
very much full in mentor, right?
yes.
All app code and ND app and
Yes. So let's go to the notebook. So
Notebook.
this is the notebook, okay, which I created, and you know this code. Like this is the code we have for the deduplication. And I'll just tell you there are two things. One is normal table, one is DLT table, delta live tables. Okay,
yes.
I have this comparison here also. Like what are the differences? You know the plain table, like what we can use this using the SQL or APIs, how to manage the schema, update, all those things. And there are
Hmm.
also DLT tables. Okay, so DLT tables are what? So they are declarative. Like we can declare the schema in the code only. We don't need to create them first and then need to write the code according to that. We can declare those in the code. These errors and all these logs are getting in that DLT log management directly. So
Okay.
we can orchestrate this DLT pipelines. I'll come to this point. This will help in our process a lot. Okay, then automatic lineage monitoring and event log. So what is this? So if you go to there are two tables I have. So this is normal table.
Hmm. You are breaking, Raj,
And this
a
is the
bit.
DLT table.
Okay. So
Am
there
I
are
audible
two.
now?
Yeah, now you are audible. You are saying dedupe input is a normal table and next one is the DLT table. And what is the
Yes.
difference if you go inside the columns, like where we can identify what is DLT and what is normal?
Okay. So normal thing for normal tables, we cannot create this table in the main code. That is the first thing. Okay. Second thing, these tables we cannot use in the DLT pipelines. Okay.
Okay.
If you go
Hmm.
to the pipelines, we cannot use those. Third thing, lineage, actually lineage supports to both right now. Previously it was just supported by the DLT tables. You can see the symbol for this DLT materialized
Okay.
view. So here you can see the lineage, you can see the main thing also from where it came and what is the final destination for this table. Like input is the input, output was
Hmm.
the final thing. Okay. And then
So
quality. Mhm.
this DLT table, are they similar to the temporary fields we create?
No, no, no.
Means
Those
they
are
are
actual
used in the
tables.
code. Okay.
Those are actually tables. We can use them in the codes also, but
Hmm.
for now you can consider them as a proper tables. Okay.
Hmm.
So the main thing is like quality. If you go to the dashboard, you need to run this quality. And what is this quality? It is inbuilt rules which are getting performed on this output table. And to the inbuilt data quality rules will give us some profiling results, same as like this. Actually the data is not sufficient for all these fields, but still we are getting some of the things like record count was 95, the main thing, how many nulls are there, on which date we run this table,
So
all
Raj,
these
one
things
question, like
automatically.
DLT table means like you are saying that data quality rules are also created for these tables, right? Automatically they will handle errors, quality checks, and all those things, right? If we are inserting email into DLT table, we can write a data quality rule for that.
Yes. So if see, if you are in a normal table, you need
Hmm.
to define these things. But if
Yeah,
you are in
data.
a DLT table, delta live tables, those
Yeah.
data quality rules are inbuilt, but we can update also them. Let's suppose if we have additional requirement, we can create that thing also.
Hmm.
So
Okay.
for that thing, we have the separate dashboards. We will go to that. Okay. Then this lineage and monitoring. So lineage we saw, and monitoring all the logs and everything. Those are also getting stored, but I'm not sure right now, like how to see all those logs and everything. Right now, I'm just aware of these two things: the lineage model and the quality. Basically, you can refer this workspace as the folder structure for us, this catalog as a databases. Okay, Then after that, let's suppose if you go to the notebook, you saw what we can do it in notebook. Okay, now we
Okay.
will go to the queries. Okay, because queries after workspace, catalog, then queries. In queries, we can write whatever we need to do in the SQL script.
Hmm.
Let's suppose this is the thing I'm writing, drop table something, or select star from the input table. Right now it will not work on this account, but yeah, here it will work. Okay, so you saw this one option there, start and run. Not here.
And Raj, this will not read any CSV file, right? If we have some CSV file, we need to dump it into some table and then we can use or create the data pipelines.
Yes, actually you need to load those first
Hmm.
uh, into the tables. Okay,
Hmm.
and once those are loaded into the table, we can read them as a table here. You
Okay.
can see like input table is my database, my schema, d2p input. So this is actually the CSV file in local machine. We need to
Hmm.
dump that first and then need to read. For dumping, we can write the notebook code.
Hmm.
That is also the option there. Okay. So queries are for that. SQL editor is like just we have the query and we need to update or run the query, anything like that. Query is just a repository to save those all queries. Okay. Now
Oh.
let's come to this thing. Notebooks are done, SQL queries are done, catalogs are done. Now we have one question here for our use case. Like if we want to extract the data from any source, let's
Hmm.
suppose Oracle, how can we do that? So we cannot write the connection properties in every notebook. We need to do
Hmm.
something. So there is one way. If we go to the catalog and we will create one thing, we will get the option for creating the connection.
Okay.
Okay, so we created this connection. Actually, I have one connection. You can see that thing. So this is the Oracle extraction. This is the catalog which I created based on one connection. Okay.
And this Oracle means Oracle database, right? You connected with
Yeah.
Oracle database, and this is again your database or
No,
okay,
no, no.
JC. Hmm.
Actually,
Okay.
I just written something.
Hmm.
These are not
Okay.
the correct credentials.
Correct.
You
Okay.
cannot do anything with this, but I just created for the practice purpose.
Hmm. Okay.
So we can create this space using that. Okay, and now whatever we will create in this space using the notebooks. Okay, let's
Hmm.
suppose if we go to one notebook, uh, let's create one new notebook. Notebook query. Okay, yeah. If we create one query, you will get one option to select the thing. Here you will select the Oracle extraction and you will paste your query here. Okay, so what it
Okay.
will do, it will create the table in that Oracle extraction using the credentials which are configured for this Oracle extraction. So right now we are unable to do complete POC because of we cannot use our credentials on this free trial account.
Hmm.
Once we will get the complete access, we will try this thing. But
Hmm.
yeah, it is
It is
working
like
like
parameters, right, Raj? What we
parameterization
use in
for the
Apex.
extraction purpose. Yes. So yeah, this is also very good thing here uh, in this Databricks, which I didn't saw in Snowflake. In Snowflake, it is very critical to do that.
Hmm.
In Snowflake, actually, we don't have GitHub support also, so
Yeah. And
versioning is
when
also different
like there are
difficult
many
there.
connectors, right? We can connect with SQL, we can connect with anything, right? Can we connect with Excel also? Like, is there any connector? Okay.
These
So
are
these,
the inbuilt their connectors, like
okay.
29 something they have,
Okay.
and the third party connectors. I think SQL warehouse. Actually, I saw somewhere that we can create the connectors, but I'm not getting that option. But yeah, here we can
Hmm.
create the connectors for data ingestion.
Okay,
Like
so it's from Salesforce, ServiceNow, Google.
these many things.
So
Excel, I don't think Excel will be here because Excel is not any source kind of thing. It is
And Google
worksheet.
Sheets, is there Google Sheets?
flat
Check.
file.
Yes, Google Sheets are there.
Okay, so
Yeah.
yeah,
Okay. Yeah. One more finding here. This five tran. Sorry. This
hmm.
is the third party application which we need to use for connecting seamlessly in between them.
Okay, okay. So this is extensively discussed in all the calls, all the bi-weekly calls. Okay, so
Yeah.
five trend.
Yeah.
What does
Actually,
like
they
for every
they are
connector
the
this?
foundation. Yes.
Hmm.
Yes. They are the foundation which are like which are acting as a broker for the third party connectors. So what
Okay.
they will do, they will connect with these things with whatever they want, but
Hmm.
from Databricks they will just take the standard credentials.
Okay. So this means 510 can also connect with Excel. We have to check it, right? If
We
it
need to
can
check. Like
connect with
here
Excel.
they haven't provided. Let me.
Upload a file is also there option.
Okay.
Yeah, this is like we can take it from our local machines
And this
from
can
here.
be integrated with blob storage also, right, Raj?
Yes, for blob storage also we can uh, do this.
Yeah, because from Azure they are very tightly integrated. So
Yeah.
maybe inside Azure we can pick up file directly from the blob and we
Yes,
can
yes,
dump
yes.
file from the blob.
Actually, in Azure, if you go to the data factory, let's suppose we are in data factory. I'm changing a topic bit for now. You have this Databricks and you have this notebook option. Okay,
Mm.
so
Hmm.
if you get this notebook option, you need to create one linked service. Okay, and in that linked service, you can directly give the credentials of the Azure instance which you have created using the Azure, and you can directly use that notebook into the data factory for the orchestration.
Hmm.
So
Yes.
there are really seamless connection in between
Hmm.
Azure and Databricks. They are really good
Wow.
combo. So that is the thing with connections. Now
Code can be
let's
written here and task flows
yes,
can be
yes,
created there.
yes. Actually, if when this is required, let's suppose something is outside from the Databricks is required in between Databricks and the source. Like we need to orchestrate with two different systems. Let's suppose we are taking something here, we are using an Azure Synapse for any analytics, and then we need to go to the Databricks, then we can use the data factory. But if we just need to orchestrate our code, our basic code, then we have these jobs. Okay, so in jobs, what is there? Let's suppose if I click on task flow, I have created this. We have three tasks. One notebook is for the Python code, normal Python code. Sorry, one Python code, one is for the Spark code, and one is for just a notebook. Okay, so if you run this thing, it will first run this Python, then Spark, and then normal, same like our task flow.
Okay.
And here also, if you want to if else statement, if you want to do some conditioning, that also we can do. So this orchestration is really good here. If you go to the jobs, and how it looks, let if you want to create something, this is job, it is actually the task flow, you can say. This is mapping task, ETL pipeline. Okay, and ingestion pipeline, that is the simple thing like from external source to
Extraction.
Databricks. But for ETL pipeline, let's suppose I have created this one, this pipeline. So in this pipeline, you can see we have created this task. Okay, but while creating this pipeline, if you let's suppose I have given some name, you need to select the sources. Okay, so let's suppose now I selected one source from this user, this Databricks and original. Okay, I also have like lot of option to select these sources. Okay, so basically this pipeline itself a tool of orchestration. Okay, so what it will do, it will run the test or original first. Okay, then if I again take one more thing, let's suppose Python, it will run Python next. After that it will run the third next. It will do the orchestration on itself first, even if let's suppose original is the first file and Python is the second file. Without original file we cannot run the Python file, but by mistake if I put this Python first and original second, then also it will run the original first and Python next. Why? Because of the DLT tables. Okay, why? Because in DLT tables you saw that lineage where it is saying it is saying like first you need to use this D2 input, sorry, use this D2 input and then this pipeline. Only after that you will be done. Okay. So after that, let's suppose the output of this thing, like output PySpark DLT, is required in the second task. It will first analyze all the lineages. It will define the sequence for them, and then it will run, even if those are not in the correct sequence. So that is great thing here also, and
Is it
we can.
integrated with AI, Raj, to do this?
No, actually, this is not integrated with AI. This is just a Spark engine behind the scenes, which is
Okay.
defining all those things. So what
Mhm.
they did, they seamlessly integrated these lineages and quality, these things with the orchestration, which is giving the good insights on the data, like which is having the priority first and which is having the priority two, and with that they can run. And for that you need to select the session. Actually this destinations or whatever it is kind of a session. You need to define where you need to run the code. So we define the code, we can create this thing. Okay, we can create this thing, and that pipeline will look like this here in this pipeline session. Okay, so once all the pipelines are ready, we can create one job. We can select those pipelines there, and while in job cannot create, sorry. Okay, so let's suppose we'll create the job. In job you will get the option to select the task. Okay, I selected as a T1. Okay, you will have the type. You can select the notebook or the pipeline which we created, or the SQL sheet, dashboard, whatever you want. You can run that thing. Let's suppose I will choose the pipeline first. Which pipeline? The one we created, Python. Okay, and once that is done, we will create this task. Okay, it has created. Now we will add one task. Let's suppose it will be from another pipeline. It will be T2. And what is the pipeline? That was the PD2 Python. It will be PD2 Spark. Okay, and it has depends on T1x. So until and unless T1 is running, it will not run. After T1 is all success, then it will run. The third one, there is UI glitch actually. Let's create from the notebook. Okay. T3. What I will select the uh, workspace. Actually, user Raj Databricks and original. This was the main notebook we have. And here also, like it will run after T2 or something. Once these all are created, I can run this now. Okay. I started the run. It will first analyze everything is meeting their standards, and then it will run. Then this and then this. How we will find that thing? In my schema, you can see right now only dedupe input and output PySpark DLT. Those two things are there. Once this complete pipeline is done, we will get three output tables. One is PySpark, one is Python, one is normal kind of thing. So let it get done, and we will find out that thing. Okay. So
And
those are the
around where
pipelines,
we
and
can we apply the transformations like those data flow transformations, those are available somewhere, or
no,
you have
actually,
to write
those,
them in SQL, right?
yes, we need to write them in SQL or notebook. Both are
Okay.
fine. Like in notebook also, if you see the main script of ours, let's see this original. Here you can see we are doing one transformation here, like Ria
Yeah.
is doing. That country mapping CH Switzerland. We need to convert this CH to Switzerland for better
Hmm.
deduplication. So that kind
Okay.
of transformation it has done here, or we can say like pre-processing. She has removed something, special
Mm.
characters, extra spaces. Those are also
So
transformations for us.
of data flow, or it might be like in Azure Data Bricks, we will get that support, right? Data flow transformations, because that is missing here.
Drag
No,
and drop, you meant to say, Kapil?
that thing
Um,
that
because
thing.
in Azure Databricks, I think they have provided all the transformation support.
No, and
It's
not
not
like
there.
that. No, it is not like that. It is like Databricks you can use in ADF, but ADF you cannot use in Databricks.
No, right now we are using plain Databricks. If we will go to Azure Databricks, do you
Yes,
think that there
still
will one more tab which will open up on the left hand
no.
side?
I tried
Okay,
that one also with the
okay.
Azure free trial account, but
So
no,
it
that
was
is
not
not
there.
there.
Okay. So this means that everything should be either done in Python or SQL, right? So that is
Yes,
everything will be the query based.
yes. Actually, the main challenge for us is the code. Let's suppose we will do it in PySpark, Spark
Mm,
SQL, or Python or SQL. Like there is not mandatory thing as a PySpark. We can use Python also. But let's
mm,
suppose for critical tasks like deduplication or something very big, we can use
mm,
PySpark. Or
mm.
otherwise for other things we will use Python. Spark SQL again for big data only, otherwise plain SQL. But yeah, we need those query level languages to done
Hmm.
all these
We
transformations.
are doing a lot, right? If we have to do a filter condition, if we have to do aggregate, sorting, so all will come towards Python if we are using Databricks.
Yes, but if we are using Azure Databricks, then we have this thing also.
Yeah, here we have the functionality for lookup for all the transformations, like some similarity with Informatica.
Yes, everything, almost everything we have here in
So
data flows. If you go to,
because Azure say that Azure Data Factory is a ETL tool because they
yes,
market Azure Data Factory as a ETL tool.
yes. Actually, what is the best thing in Data Factory? It is like a umbrella for all the services.
Hmm.
You can create the ETL flows here in the data flow, but if you go to the pipeline, you can do everything. Like you can use Azure functions for the API calls and everything, Databricks for our analytics, Azure Synapse for the analytics, all the things.
And
So
where
it
do
is
we
like,
see functions here, Raj? Those
so
pre-built transformations in
okay,
functions,
so
eh?
you need to create this data flow first. In data flow, you can see those.
Hmm.
Okay. Once this
Hmm.
data flow is created, you need to go to the pipeline and you need to drag this data flow.
Hmm.
Yeah, here, data flow. Take this data flow, configure it, give this location to there, and done.
Got it.
Just like this. So it is kind of pipeline, Kapil, where we can use the
Hmm.
data flows and all the things. But in Databricks, we don't have. Databricks is completely a critical analytical tool.
Yes.
But yeah, it is easy if we understand these things. Like those are really easy. For example, let's suppose here somewhere we are yeah doing this pre-processing on the address lines. So this pre-processing text, we created one thing here.
These
Okay.
notebooks can be reusable, right?
Yes, yes, those are usable. And we just need to give the like coding. If we are learning, then it is easy. Otherwise, yeah, scripting, that is one of the critical tasks here.
And Raj, you explored Ginny as well. Like Ginny is their
Yes,
co-pilot.
yes,
Okay.
I have written it in Chini for the magic dashboards for internal access. I'll just show you one small thing. Actually, I'm not the completely aware of all the things here, but still I
And
managed to create this dashboard.
we are on the top of the time as well.
Ah, yes.
So we already spent 1 hour. So maybe if all of us like, we can continue this series on for some time till the Paramount is coming into full focus.
Yes,
Yeah.
Kapil, that would indeed be
This is
very useful. Like this
And
session,
some, yeah, you can also pick up these topics. So maybe Lukman, you can also pick up some topic of your choice. I will pick up from my side. So everyone can share some of your thoughts. Nagendra, you can pick up something on Azure functions, which is related to CI and the API calls. So in that way, it at least the good part will be that we will learn up one of the very niche technology. So Databricks is now a leader in the market, so no one can ignore this technology for sure. So let's do it.
in this free account only these things are there which we cannot do.
For the account, what I can do is I will send an email to the this JCI CSM. So she has sent me a mail yesterday like I can support you on Databricks. So let me test if she can provide us some space, or I can also request data analytics team if they can provide us some accounts to do this thing.
Yes, like it is really nice to like I went through all these points. I tried most of them, and yeah, really good one. We can do a lot of things like see
You guys can
this
also
kind of
think in
dashboards.
the point of view of migration, like if we want to transform those things, if we want to take out our things from Informatica, how it is possible. So put some thought around it, like it's not mandatory, but if it is possible, then let's try to do it. Majorly like filter thing, aggregator things, like most of the things which we are doing in our mappings.
Yes, only this section is not used by us. Otherwise, all things we need.
And at least if we reach up to data engineering, that is also very nice because we all are data engineers. So at least we should know up to pipelines, how to create them, how to utilize them using
Yes,
Python code.
yes,
Okay, then maybe we can continue tomorrow on this at the same time. And thank you, Raj, because this interface, you go through it, and it was very nice. Like we understood what how the UI looks like, and it give more confidence to everyone. Okay, like when
exactly.
everyone feels that we are very much familiar, we can do it. Then all of us can try out some things on it. So
Yes,
yes,
Kapil,
yeah.
it was indeed a very great effort from your both your ends, Kapil and Raj.
It's our team effort because without our audience, we cannot do anything. And you guys are participating, asking so many questions because see, I believe like if we will collectively study, it will be useful for all of us right now because of short span of time now, right now these days. Like you send that article, Lukman, like after in every 30 minutes we are picking up our mobile, checking notifications. So nowadays, like it's very difficult to for the solo studies, and even when we are in jobs it become more difficult to do the same kind of college study thing, which is possible in groups.
Exactly.
So,
yeah. It is
okay, Raj, and
really great thing to learn this thing. Actually, with Azure, this Databricks is getting like another level of powers.
yeah, actually they and Fabric is also coming. So when
Yes,
actually they are putting all the pieces together now. Fabric plus Databricks plus ETL tool Azure Data Factory plus Power BI. So I think like this combo is very helpful for people who are doing who are in this space, data analytics. So everything is available on this side.
yes. Yeah. So for the last one, we generated all 3 tables which we run in the task flow which we created.
And how many different types of clusters are there? Small, we can see small, large, something like that they have created, Raj. Small
We need
cluster,
to
large.
specify. We need to specify first whatever the size, how many CPUs, how many GPUs we need to do there. It will come under the compute actually. If you go to the
Okay.
compute
So like in
here,
Snowflake, they have XL, double XL, small, like t-shirt sizes. Here it is size is
uh,
small. You can
that
click
is
on
for
size.
warehouse. That is for warehouse.
Okay.
Warehouse and
Okay.
clusters, two different things.
Okay.
We
Again, here is same thing. Small, medium, large X. Okay.
And these are auto selective, right, Raj? Or we have to specify?
need to specify.
Okay. In Snowflake, I remember it was auto, right, Kapil?
I think we have to create a cluster first, and
Yes,
yeah, auto select was there, but always they select the smaller one, and then if we want to increase it, we can increase it. But because when Ria was presenting, she was saying that I will start the warehouse first, like last time when we were in this Python session, dedupe session.
yes. Here also we need to start the warehouse first, but if we run anything, it will get started automatically.
Okay.
And the clusters, we need the clusters only for the PySpark, like for the distributed computing. Otherwise, this warehouse will do almost everything. Just it is unable to do the multi-processing. Clusters
Mm.
are able to do that. Only that thing is
And
differently.
Lukman, you have not created any Azure account, right? Or you also created an Azure account?
No, Kapil, I did not.
If you are not created, you can then try creating it from your JCI ID because like 30 days Azure account is free for all of us.
I tried
So,
doing it few days ago, Kapil, but it was saying
mm,
that it is like you are an older user, and I believe it is because we had these accounts for data ingestion activity.
okay.
But I can do it with some other email IDs.
No, if you
Other
use
email IDs,
another
they are
email
not
ID,
accepted.
then it will ask for the payment
Hmm.
cards or anything.
I'll check with the Raj once, Kapil,
Mm,
anytime today and tomorrow, and try to create an account.
Only thing is with different account Kapil is like they are saying they will not charge anything for those things. But if we research furthermore, they are saying Databricks is not a free service there. Okay, so only
mm,
that is the issue there. If we will get some charges there, but again in Databricks, if we want to create the Databricks environment, they are
mm,
saying there is 3 options. One of them is the premium for 14 days free trial.
okay.
I'll just show you.
No, what you are
Uh,
saying is if we create a account in Azure, you are saying that we will not get Azure Databricks there in the free account of Azure.
they are saying that thing. Like you will
Okay.
not get Azure Databricks as a free service with the free trial account.
Okay.
Now this is our JCI one. I'm not creating. I'm just showing you. Let's
Mm,
suppose if you want to create, we need to select the subscription. These two are there, but with that we have the pricing tiers. So
mm.
there are 3: standard, premium, and trial.
Okay.
So this is 14 days free DPUs. I'm sure like for 14 days we will not face any charges, but
Mm,
I'm still not completely sure on that thing.
mm.
I just
Okay, I
need to
will
do some
discuss with
research, and if
Ravi. So maybe I will discuss with Scott, like if we want to practice something on Databricks, can you provide us some free accounts? Let me drop an email to them.
yes, uh, that is happening, then yeah, it was really great. We can do it on major scale.
Mm. Okay. Okay, then I think we can stop now because Malti has another customer master session in 15 minutes. We can take some break,
Yeah,
maybe tea and coffee, and then connect again.
yeah.
Okay, thank you all. Thanks everyone for your
Thank you,
participation.
everyone.
Thanks, everyone. Thanks, Raj. Kapil.
Thank you, Kapil. Thank you, Raj.